Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about rational expressions, which is like your introduction to calculus. So let's start by just doing some simple rational expressions with no variables, and then convert it over to variables for each type, which we'll go multiplication, division, addition, subtraction. Okay, so the multiplication of rational expressions is super easy. All you have to do is multiply the top and then multiply the bottom. So 3/5 times 7/2 is 3 times 7, which is 21, and 5 times 2 is 10. Then you just have to look. Can you simplify this? No, you can't. 21 over 10 can't simplify, but you could just factor it out, which you could always do to see if you can simplify. It'd be 7 times 3 over 5 times 2. Again, like we had, you just can't simplify anything. Okay, then we have 4/9 divided by 2/3. You may recall that when you're dividing by a fraction, you just flip the fraction that you're dividing by. So this will equal 4/9 times 3/2 instead, and that equals 12 over 18. But what you could also do is see when you're like multiplying, you could see, okay, you could like cross check. So 9 and 3, could you simplify those? Well, you could. You could say that is 9 goes to 3, 3 goes to 1, and then 4 and 2. Could those simplify? Of course, 4 could go to 2, and 2 could go to 1. Also, you could just check with just check every number with the numbers on like the other side. So check 4 with 9 and 2. 4 can't do anything with 9, but it can with 2. And check 3 with 9 and 2, then 9 with 4 and 3, and 2 with 4 and 3. So check with both on like, if you're checking a denominator, check both on the top. Okay, and this will be 2 over 3, which is simple enough because you can see if we did divide these by 6, this would be 2, and this would be 3. Okay, so 2/3, 21/10. Okay, now is where it gets a little more difficult, but with no variables, it's still pretty simple. When we're adding rational expressions or subtracting, you have to find a common denominator. So if you did 5/7 plus 1/2, you have to have a common denominator between the two. So you say, okay, 7 and 2. What is the common about those two? Well, if you tried to factor them out and find a common factor, all you'd find is 1, because 7 is 7 times 1, and 2 is 2 times 1. So an always common denominator will be 1 times the other. Usually we look for a least common denominator, but in some cases, where it's just 1 times 7 and 1 times 2, you are going to have to like multiply the 2, and it will be the least common denominator. So what 7 times 2 is it's 14. So we need a common denominator of 14. So how do we do that? Well, 5/7, if you want to make it like something over 14, you'll multiply it by 2 over 2, which means you're multiplying it by 1, so it stays the same. So this will be 10/14 plus then 1/2. If you want to turn that into something over 14, you have to multiply it by 7 over 7, because that 2 times 7 would be 14. So 1 times 7 is 7, and 2 times 7 is 14. So then if we add those, 10/14 plus 7/14 is 17/14. And then you can't simplify that. All right, now we do subtraction. I say 7/10 minus 3/4. Well, can 10 be simplified into anything lower? Like what can it be factored? Yes, it can. You can factor this into least common factors would be 5 and 2. So it'd be 7 over 5 times 2 minus 4. Can 4 be factored into anything? Yes, it can. It can be 2 times 2. So this will be 3 over 2 times 2. Now you see that like 2 appears multiple times. And the thing is, that just means you need 2. But what I'm trying to get at here is you could take away like one of the 2's. If you just need to stay with 2, so if there's a 2 in each, you could just take 1 2 away. Like you could just say, okay, you don't really like need that for the least common denominator. So you just do 10 times 2, and it would give you 20. So this would equal, if you want to get 10 to 20, you'd do like times 2 over 2, and you'd get 14 over 20. Minus, if you need to get 4 to 20, you'd multiply by 5 over 5. So you'd get 3 times 5 is 15 over 20, and that'll equal negative 1 over 20. I hope that kind of made sense with the least common denominator thing, because if you were to just multiply 10 times 4, you would get 40, right? And that is not the least common denominator between 10 and 4. It's 20. So what you can do is if you factor these out and you see a number that appears like twice, like once in one and once in another, in your calculations for least common denominator, just don't factor in one of those. So I see a 2 in both of these, and I'm just saying, okay, one of these 2's, I'm just not factoring that in. And that'll be 10 times 2 gives me 20. If I did factor in that 2, it'd be 10 times 2 times 2, which would give me 40. Which is exactly what this is. Okay, I hope that kind of makes some sense. Okay, now we're going with variables. Multiplication, super easy, just multiply across. So x plus 2 over x times 7 over x minus 9 is equal to, you just do 7 times x plus 2 and x over, well, x times x minus 9. And then you can just see if anything simplifies. It doesn't, and you don't really even have to factor out. Well, like you don't have to distribute. Okay, now x squared minus 4 over x divided by x minus 2 over x squared plus 2x. Remember, when we're dividing by like a rational expression, you flip the one you're dividing by. So we'll have x squared minus 4 over x times x squared plus 2x over x minus 2. And then you may just say, okay, well, I'll multiply across. But you can see if this simplifies it all. X squared minus 4 is a difference of squares. So this will be x plus 2 times x minus 2 times x squared plus 2x. You can take an x out of that and have x times x plus 2 over x times x minus 2. And look, x minus 2 cancels, x cancels, and what you'll get is x plus 2 squared will be your final answer. And see, x plus 2 squared is a lot simpler than x squared minus 4 times x squared plus 2x over x times x minus 2. X squared plus x plus 2 squared, so much simpler. Okay, now that we've done division and multiplication, super easy. You shouldn't really even have to think about those. You're just like, oh, flip, or just, oh, multiply across. Now we get to addition and subtraction. So we have 2 over x plus 3 over x plus 1. Think, okay, can you factor out x? No, you can't. Can you factor out x plus 1? No, you can't. Like if it was like 2x plus 2, you could go, oh, 2 times x plus 1, but you can't. There's nothing you can do here. So you just have to do x times x plus 1. So to get x, well, first just say like, okay, least common denominator. We know that we need an x and we need an x plus 1, and there's no easy factors. So it just has to be x times x plus 1. All right? So to get 2 over x to be like something over x times x plus 1, you have to multiply by x plus 1 over x plus 1. So we'll have 2 times x plus 1 over x times x plus 1. Right? And that's our least common denominator. Good. Now, 3 over x plus 1. To get it to something over x times x plus 1, you have to multiply by x over x. So you'll get 3x over x times x plus 1. Right? And now all you do is you just like add across. 2 times x plus 1 is 2x plus 2, plus 3x would be 5x plus 2 over x times x plus 1. And then you say, is there anything you can simplify? You can't take anything out of 5x plus 2, so no, this is your final answer. Now, let's do that is supposed to be a subtraction sign. Sorry about that. subtraction. Okay, x plus 1 over x minus 2 minus 2x over x plus 3. Again, we don't see anything that we can take out here. So we know that our least common denominator is just going to be 1 times the other. So it's going to be x minus 2 times x plus 3. So to get x plus 1 over x minus 2 to something over x minus 2 times x plus 3, all we have to do is multiply by x plus 3 over x plus 3. So this will be x plus 1 times x plus 3 over x minus 2 times x plus 3 minus, now to get 2x over x plus 3 to something over x minus 2 times x plus 3, we have to multiply by x minus 2 over x minus 2. So I'll have minus 2x over x, well, 2x times x minus 2 over x minus 2 times x plus 3. And now we'll just say this is equal to x squared plus 4x plus 4 plus 3, x squared plus 4x plus 3 minus, this will be 2x squared minus 4x, which if you distribute that, this will be minus 2x squared, and then this will be minus 4x, but the negative that will be plus 4x over x minus 2 times x plus 3. Now if we simplify all that, we have x squared minus 2x squared is negative x squared. 4x plus 4x is plus 8x, and then we have a plus 3 over x minus 2 times x plus 3. And then you may say, okay, this is negative x squared plus 8x plus 3 over x minus 2 times x plus 3. And then just see. Oh, that is a negative negative. Just see, okay, is there anything that multiplies to negative 3 and adds to negative 8? And I don't believe there is. So this is our final answer. Negative x squared minus 8x minus 3 over x minus 2 times x plus 3. So you can see that it gets a little harder when you add variables, but especially addition and subtraction, try to find that least common denominator. And if you have something like x plus 1 over x squared minus x, right, plus x minus 2 over x plus 1, what you'll see here is that this goes to x times x minus 1. Actually, let's turn this x plus 1 into x minus 1. So you wouldn't say x squared minus x times x minus 1 is your least common denominator. No, you would factor out one of these and say, okay, this is equal to x times x minus 1. So really, the least common denominator is x times x minus 1. So you just multiply this by x over x. Okay, I hope this video is helpful. Please comment if you have any questions. This is decently complicated, and I hope to see you again. Please like and subscribe if it was helpful, and good luck.